Good morning, everyone. This is Shrikant. Welcome back to Excel Vidyarthi, all of you. So today we have a very important problem, which is arrangement of three number of circular cylinders. Okay. So this type of questions were many number of times asked in the B.Tech first year semester exams. All of you, many number of times it was asked in the B.Tech first year semester exams. Okay, all of you. The question can be like this. He might be asking the reaction forces at all the contacts. Okay, he might be asking reaction forces at all the contacts, or he might be asking the tension force in the string that is connecting from A to B. Okay, all of you. So let me read the question. What is was expecting in the question? Let us see, all of you. Okay, so two smooth circular cylinders, smooth in the sense the surface are what we can say, smoothness in the surface are non-roughness. That means we can say the coefficient of friction is equal to 0. Therefore, no need to consider any friction force here. Okay, all of you. Each of weight W 1000 and radius 15 are connected at their centers by a string AB of length 40 centimeters. The length of the string is 40. Okay, fine. And rest upon a horizontal plane, supporting above them a third cylinder of weight 2000. Okay, and the radius is 15 centimeter as shown in the figure. Find the force S in the string AB and the pressure produced on the floor at the point of contacts D and E. He was asking you to determine the force acting in the string, at the same time the pressure at D and pressure at E. Can you say, all of you, what are these pressures? Pressures are nothing but the reaction forces. Okay, can I say a point, all of you, that because of these weights, because of these weights, okay, the entire system is producing some action on this floor or not? So this is producing some action on this floor. Okay, all of you. Then what the floor will do? The floor will definitely provide some reaction force onto the bodies or not? Yes. So these three are producing some action on this floor. Therefore, he was asking what is the reaction force that is provided by the floor on the surface. Pressure means what? Action and reaction. Okay. Now, here all of you, how many bodies are there? First of all, three number of bodies are there, A, B and then C. A small doubt. To many students, this doubt will be there. Sir, here the weight is 2000. Here we have 1000. Here we have 1000. But all the three are having same radius or same diameter. How it is possible? Okay. The point is what, all the three are having same radius or same diameter. That is okay. But the point is all the three may not be made up of excuse me, all the three are not made up of same material. If all the three are not made up of same material, okay, different radius or the same radius doesn't matter, all of you. I am saying once again, repeating all of you clearly. Okay, these three are having different weights. Okay, but these three are having actually what? Same radius value. Means what? All the three are made up of different materials. Okay, so don't need to worry about radius and no need to worry about the weight. Okay, all of you, I am starting the question, all of you. So please try to observe this figure clearly here in this case. Very good question it is. Okay, now we have to draw the free body diagram. Totally we have three number of bodies. No need to separate all the three. Sometimes we need to separate only one. Sometimes we need to separate only two, depending upon the given problem, all of you. Okay, so first of all, the thing is, I am taking the entire system as a single body. Okay, ఈ త్రీ బాడీస్ని కలిపి ఒకటే బాడీగా అజ్యూమ్ చేసుకోండి. If you take this total system as only one single body, then what happens, Then what becomes the free body diagram, We have a reaction force here, all of it, that is nothing but what? Nd. At the same time, we have one more reaction, that is Ne. Wherever we have a contact, you will be having the reaction force. Remember, all of you, I am not separating these bodies. I am taking these three bodies as only one single body. I am taking these three as only one single body, all of you. Okay, therefore this becomes what you know, the reaction for nothing but n suffix d, one second, n suffix t, and this will become the reaction for nothing but n suffix e. Am I right, all of you? It's over. This is fine, clear. Okay, so next one please. Next one. What about the weights? So here we have weight, that is I'm marking here like this. This is a weight 1000. 1000 is there. Okay. 2000 is there. Okay. And here we can have definitely what you know, 1000. Okay. So these are the only force we have, all of you. Now I am applying the equations of equilibrium. Can you say what are the equations of equilibrium, all of you? So one will be summation of fx, you know very well. Okay, and one will be summation of fi, all of you. Okay, and one will be definitely summation of m is equal to 0. Moment equation. Tell me, all of you, when you will apply this equation. If you want to apply, we need some force in the x direction. But tell me, all of you, in this body, on this entire system, do we have any horizontal forces? There are no horizontal forces here. Therefore, it is not required. But we have vertical forces acting in the y direction. Therefore, I am applying this equation. So, what is sigma Fi? Okay. So, Nd is acting upward. I am taking positive. Okay. Yes. Ne is acting upward. You can take it as positive. Next, 1000 is acting downward. Take it as negative. 2000 is acting downward. You can take it as negative. And again, this is also acting downward, negative. Therefore, I can say finally, n suffix d plus n suffix e will be how much? Definitely, you know, 4000 is the value. Here is the picture. There is a case. Okay. Then what about sigma m? What is sigma m? Summation of moments is equal to 0. But for writing this equation, definitely we have to choose a moment center. Okay, tell me, all of you, where you will choose moment center. Any point you can take. Okay, so just see, all of you, I am taking the convenient point as point D here. I am taking D as moment center. If you take moment center as D, the moment of ND will become 0. And you can bring out NE or not. Again, if you take moment center as E, moment of NE will become 0. And you can bring out ND or not. Yes. Again, repeating, all of you, if you take any moment center, the force that is passing through that moment center, okay, its moment will be definitely equal to 0. Now here ND is passing through D, therefore moment of ND is becoming 0. Now NE is passing through E, moment of NE is becoming 0. There is a picture. Okay, if you take moment center as D, 1000 is also passing through D. Okay, therefore I am writing moment center as D, all of you. You can take moment center as E also, same answer you can get. Okay, therefore I am writing the equation of, listen carefully, right. Now if you take, just see here, if you take moment center as D, moment of 1000, moment of ND will become 0. These two moments will become 0 because these two are passing through point D. Over. Now with respect to point D, what is the moment of 2000? With respect to D, this 2000 is providing which direction moment? Clockwise moment. With respect to D, it is providing a clockwise moment. Okay, but what is perpendicular distance? So this is the force, all of you. This is the force, and this becomes distance. You can check, all of you. Okay, so this becomes the line of action of the force. Can I say, all of you, this will become your perpendicular distance or not? Yes. Okay, and this producing in which direction? Producing moment in clockwise direction. Now, what is the moment of 1000 here? 1000 is acting in the downward direction. It is producing moment in this direction, all of you, like this. So force into distance is how much? How much? 40. So this is moment center. This is the line of action of the force. Okay, this is the line of action of the force we have, all of you. Okay, therefore I can say force into distance. How much? 40. Move in which direction? Clock. That's it. What about the moment of NE? NE into distance. NE into distance. Moving which direction? Anti-clock. Force into distance. Anti-clock. Okay. Therefore, I am writing all of it clearly here. The statement. So, 2000 into these how much? 20 distance all of you. Plus, what about the moment of 1000? So, 1000 multiplied by 40 distance clockwise, but N is providing an anti-clockwise moment. Am I right, all of you? Check it. With respect to point D, N is providing an anti-clockwise moment. Anti-clock. Therefore, I can definitely say minus NE into distance is how much? 40 is equal to G overall. Okay. So therefore, once again I am repeating, with respect to D is providing clock, but with respect to D is providing anti-clockwise moment. And moment of 1000 is becoming 0 because it is passing through point D. If you take moment center as E, moment of NE, moment of 1000 has to become 0. Now from this equation, can you bring out the value of N suffix E or not? Yes, definitely we can bring out. After getting NE moment, after getting the value of reaction force at the point E, okay, you can substitute this NE value in this equation. Am I right? You can check. Okay, you can substitute this NE in this equation, all of you. Now after substituting this NE, can I say that ND will be definitely equal to 4000 newtons minus the value of N suffix E. Am I right, all of you? Definitely. Is the case. So can you bring out the value of N suffix D in the problem or not? Definitely we can say. Now we know NE, we know ND. Okay, so this completes the 50% of your problem. Okay, now just see what is the next case. What he was asking, find the force S in the string. So the pressure exerted on the floor is over. Pressure means what? Reactions at D and E. Pressure is over. Now he was asking to determine the string force acting. So what he will do? The string is here. This is the string actually. Am I right? This is the string we have. Okay. Now do one thing, all of you. You have to separate the bodies. No other alternative. Okay. So if you want to calculate the string here, we have to separate this body. Am I right, all of you? But before separating this body, we have to separate this body. Why? Because if you want to determine the reaction force at this point, if you want to bring out the reaction force at this point, definitely we have to separate this body, determine the reaction force here. Okay, then we can separate this body, can determine the tension force in the string. Therefore, two number of bodies we have to separate minimum. Okay, therefore, or you can separate these two. These two will get the same answer because the string is connecting from A to B. A to B. There is a picture. A, B. All of you. I am separating the body. See, first of all here. Very simple. 1 second. I am separating body so you can check. Have some patience, all of you. I am just saying everything clearly and perfectly. Should have some patience. Okay, my dear students. These are the things we have. Okay. Okay. So this one is actually the body C. Body C. Okay, all of you. So first thing is what? I am providing its weight downward. 2000. Okay. And here we have a contact. So you'll be getting some reaction force. Next. Here also we have a contact, all of you. And here also you'll be getting some reaction force. That is the case. Okay. So let me mark some contact points, all of you. I am marking some contact, check all of you here. Contact, so A, B, C, D are there, no? Let me some, for example, X I am taking. There is some Y. X, Y are the contacts. Therefore, it becomes what, reaction force at X. At the same time, we can have the reaction force at Y. That is a picture. Okay. Now tell me all of you, what about the case of the diagrams? How we can determine the geometry is a very important thing here. Geometry. Geometry is very important because we have to bring out some angles. For that, I am just joining this one. Joining this. This is the case. Are you following all of you? So this is the case we have. Now in this triangle, okay, let this angle be for example theta 1, and here also I am taking this one as some angle theta 1. Okay, and you can separate this triangle here like this. Can you say what about this triangle's hypotenuse side? Check it. 1 second. I'm just bringing this triangle outside for you. So 1, 2, this one is 3. This is the picture. Okay. Can I say this will become 20 centimeters or not? Yes. And can I say what this side represents? This side. 1 second. What this side represents? Can I say this becomes the radius of both the bodies or not? I can take radius of this body and radius of this body. Both are having same radius. Okay, therefore I can say if it is a radius, can I say this become definitely radius is how much? 15. Therefore I can take it as how much? 30. And this becomes some angle theta 1. Okay, so from this equation, by writing just tan theta, okay, can you bring out the value of theta 1 or not? Yes. Sine or cos or tan, you can bring out theta 1 definitely. Okay, now I am placing this angle theta 1 here. Over. Okay, somewhat lengthy question, you should have some patience all of you. At the same time, this is also equal theta 2 I am marking. Both are same angles all of you. Theta 1 only I am marking, no need to worry. 1 second. So this will become the angle theta 1. Again, theta 1 is the picture. Theta 1, and this becomes again theta 1. Okay, and this becomes the weight of the body. What is the weight of the center body? Tell me. 2000 is center body weight, all of you. How much it is? Is the picture. That's it. Okay, are you following all of? Yes. Now we shall go for the application of Lami's theorem here. Or you can apply equations of equilibrium, it is your wish. Okay, so better here I am applying equations of equilibrium. 1, this one is 2. Okay, x-axis, y-axis. You place all the forces, all the 3 in this equation, in this position, in this coordinate system. W, next thing is ny, next thing is nx. Nx, nx it is, ny it is. This becomes what? W. Okay, so this will become again theta 1, and this has to be again theta 1. That's it all. Theta 1 you can bring out from here. Very simple. I am applying the equations of equilibrium, all of it, that is summation of fx is equal to 0. Okay, so by writing we can have minus n suffix y. I am resolving, all of you know resolution very well. So ny cos theta 1. Next thing is ny sin theta 1. Next thing nx cos theta 1. Next nx sin theta 1. Am I right, all of you? Perfect. Okay, so minus ny cos theta 1 plus nx cos theta. You know very well, all of you. Left I am taking negative, right I am taking positive, all of you. Okay, is equal to 0. Now I am going for summation of fy is equal to 0. Okay, fy is equal to 0 we have. nx sine theta 1. Okay, so plus n suffix y sine theta 1. Okay, so minus w is equal to 0. And this one is having weight 2000. Be careful about this 2000 here. Okay, now we just solve these two equations. By solving these two, definitely we can bring out nx is equal to some value, ny is equal to some value. You can get. Am I right, all of you? Yes. Therefore, now we have determined the reaction force at this point x. At this point x, we got the reaction force. This is the point y. This y is not required for us. Okay. Now I am going for the lower body, all of you. This body I am going, all of you. Okay. For this lower body, how many contacts are there? We have contacted D and contacted X. So two contacts will give two reactions, and we have a string, we have the weight. Again repeating, for this body we have reaction, weight, and the string. Okay, right. Don't worry about string direction. You can just assume like this. This is acting in this direction, tension, and this is acting in this direction, tension. Okay, so don't worry about tension. I'll explain here. No need to worry. First of all, let me draw the complete diagram here. I am discussing the free body diagram for the lower body, all of you, nothing but the body A. Okay, one second. Let me draw the diagram. Within 1 minute, we can complete the problem, all of you. So this is the case. Lower body diagram I am drawing, all of you. Please check it. First thing is we have a base, horizontal base. I am providing a vertical reaction, all of you. So reaction force will be perpendicular to the surface. You can check my previous recordings, everything was done there. Okay, from the center we have to provide some tension force T, and this tension force T is given as S. Check the question. The force acting in the string is given as S. This can be also called as tension T also, no need to worry. Okay, and here we have a contact X. It becomes N suffix X, reaction force. Am I right, all of you? N suffix X is the case. Next one. Next thing is the weight acting from the center. Okay. So this is the point of D. N suffix D it is. Okay. It is N suffix X, I told. This becomes the point AB. That's it. And this becomes the weight of the body. 1000 is given. Okay. Now we can do one thing. Angle theta 1 with the horizontal. Place the coordinate system. Have some patience. This was lengthy question. You have to do no alternative. It is X. It is Y axis. Now you place all the forces in this quadrant. So therefore, we will be having finally ND acting upward. One second. Yes. ND is acting upward. Next thing, weight is acting downward, all of you. Okay, and here we have some string tension force, and here we have some NX like this. Okay, so N suffix S X theta 1, weight is equal to 2000. Please check, weight is 1000 or 2000? 1000, sorry. Weight is 1000 we have. $1,000 is the weight we have. This one is the tension force or the string force. Okay, remember all of you, tension force will be always acting away from the body only. We are considering this body, right? From this body, tension force will be always acting away only. That's it. Okay, and this becomes the reaction force actually at the point. This is the case. Okay, so now I am applying this equation of equilibrium, summation of fx is equal to 0. 0. So minus nx cos theta 1 plus s, okay, is equal to 0. Next, summation of f5. So I told resolution already. This becomes nx cos theta 1. This becomes nx sin theta 1. Okay. So if you apply sigma fi 0, nd minus w is equal to 0. nx is already known for us. Got the point all of you clearly? nd is already known for us. These two are already known for us. Okay. Now if you substitute, you can bring out the value of s. And even there is no need of this equation also. ఇది మన రాయాల్సిన అవసరం కూడా లేదండి, ఇది ఒక్కటి రాసి చాలు. ఆర్ ఇఫ్ అని, బట్ ఇది కావాలంటే మీకు కంపల్సరీ nx కావాలి. ఓకే, nx ఎక్కడి నుంచి తీసుకొచ్చాం? దిస్ బికమ్స్ nx value. I told just now. You can bring out nx like this. Okay, so all of you, this type of questions might be given for a semester, and this question is given for 15 marks. 15 marks की question ఇచ్చేయండి, అంత ఇంపార్టెంట్ ఆలోచించండి. ఓకే ఆల్ ఆఫ్ యూ, సో డోంట్ మిస్ దిస్ టైప్ ఆఫ్ క్వశ్చన్స్ అండి. ఇలాంటి క్వశ్చన్స్ 2-3 సాల్వ్ చేస్తే ఈజీగా మీరు క్వశ్చన్ పేపర్ నుంచి బయటపడిపోవచ్చు. At the same time, you can score, even you can score full marks in the semester examination. Okay, so all of you, please subscribe to my channel to get the live updates about the classes. Okay, soon I am going to start the free course which involves the solutions of all the previous question papers for all the state universities across India. Okay, so anybody can join this course. Thank you all of you. Bye. Have a good day.